So in this example, we're actually going to be reverse engineering what we did in example 1, going from a mixed radical to an entire radical. So we need to look at basically what we would have had in A to give us 7 root 2. Well, we know that in order to get something out from a root sign, we had to have a group as big as the index, meaning in this case we would have had to have a pair of them. So what we would have had at some point inside that root was the square root of 2 times 7 times 7. All that's left is to simplify this out and actually multiply out 2 times 7, which would give us the square root of 98. So we're just trying to reverse engineer what the original question was. Same idea in B, but now with variables. We have a to the 4th times the square root of a, and I've been very intentional in leaving a little bit of extra space between the exponent and the root, just to be clear what it was. But what we would have had under the root in B, we would have had this a that was here, and we would have had 2 sets of a to the 4th. Simplifying it out, we have to multiply with exponents, which means we're adding the exponents. Keep in mind that on this a here at the front, it was an exponent of 1. Like I said before, we never write an exponent of 1, but it's assumed to be there, and right now we need it. So when we multiply with exponents, we add the exponents. 1 plus 4 plus 4 means this would have been a to the 9th. That is an awful looking 9, so I'll try one more time. Clear the page to do example C. Here we have 5b times the cube root of 3b squared, which means that we would have had under the root this 3b squared that was left over, and we would have had 3 sets of 5b. Because of the index of 3, we needed a group of 3 to pull out, so that's what we would have had to have. Simplifying this, do it piecewise. 3 times 5 times 5 times 5 would be 375. Again, each of these b's would have had an exponent of 1. Multiplying with exponents, we'll add them. So we would have had 375b to the 5th.